This is a presentation on voltage measurements with differential amplifiers by Mary Neal. Why is a differential amplifier useful for acquiring voltage measurements at the surface of the body? Firstly, what is a differential amplifier? A differential amplifier amplifies the difference between the voltages measured with respect to a common reference, usually the ground. The difference in voltage is usually measured between silver-silver chloride electrodes, but other metallic electrodes, such as stainless steel, can also be used. So why is this useful in the body? The body is largely composed of conductive fluids. Electromagnetic fields, such as those surrounding the electrical equipment and wiring, can induce electrical currents within the fluids. Typically, these currents alternate at mains frequency, about 50 Hz. We need to extract far weaker signals from the noise generated in the body and in the equipment. How does the differential amplifier work? Potentials coming from the organs being measured, such as the heart or brain, affect one of the inputs of the amplifier more than the others. This difference in signal is called the differential mode signal and is amplified. Potentials arising from electromagnetic interference and noise affect both inputs equally. They are also equally likely to be picked up by the leads connecting the electrodes to the amplifier. These are called common mode signals and are largely rejected depending on the common mode rejection ratio of the amplifier. Why is the reference electrode important? This illustration shows a simple setup for an ECG. Electrodes are attached to the shoulders, and the right leg is usually attached to the ground electrode. Almost all techniques for electrophysiological recording employ a differential amplifier, in which the potential difference between a reference electrode and the ground electrode is effectively subtracted from the potential difference between the recording electrode and the same ground electrode. Ideally, the potential on the reference electrode would reflect only contributions from the noise sources that are also picked up by the recording electrode. The degree to which the differential amplifier can reject noise common to both terminals is called the common mode rejection ratio. Cardiac signals are only a few millivolts, so would be swamped by the background noise without a differential amplifier. The common mode rejection ratio is the ratio of the differential mode gain, which is the gain applied to the potentials not appearing on both electrodes, to the common mode gain, the gain applied to potentials common to both electrodes. It is measured in decibels. Most amplifiers have a high common mode rejection ratio, about 90 to 100 decibels. This means that the differential mode gain is about 31,060 to 100,000 times greater than the common mode gain, meaning the required signal is now easily recorded.